Good afternoon to all. Today I will discuss about furnace. It is under unit 2. After end of this lecture, student will able to learn about the crucible furnace, cupola, induction furnace, reverberatory furnace, open hearth furnace, arc furnace, and casting design consideration. About that things they will learn. First, melting and pouring by using a furnace. So, for requirements, what are the requirements for furnaces? First one, provide the required temperature and also required quantity and quality of that particular things. Then again, do not contaminate the metal, means do not mix with any impurities to that particular metal. And another thing, the pouring which is done by the furnace, that another thing is important thing, that is the economical, that will be economical. Another thing, to control the melting process when the additives are mixed with the metal. So that things are requirements for the furnaces for melting and pouring. Now we are coming first discussion about cupola furnace. So that cupola furnace made by Rene Antoine around 1720. Cupola is a melting device. Another that used for melting of the cast iron. Okay. Another some other metals like bronze also used as a charge material. In case of cupola furnace, flax, coke and metal has been used. Another, scrap of blast furnace, different scrap materials also created to that blast furnace, that also be remelted again to the cupola furnace, means in crucible furnace, that is cupola furnace. Another, large cupola furnace, very big size furnace may be produced up to 100 tons per hour of hot iron. Every day they will produce per hour 100 tons. A big size or large size cupola may produce up to 100 tons per hour hot iron. Means melting iron they will produce. Construction of that particular cupola furnace. Cupola furnace, the shape is as like cylindrical shape, means as like cylindrical shape, and it will kept as a vertical. Okay, and the shell, means the membrane of that particular cupola furnace is made by steel. Steel, we know steel as a corrosion resistance material, so it will does not form any oxides with that particular steel material. Another, the size of that particular cupola furnace expressed by diameters, and the range vary from 0.5 to 4 meter, and that furnace will be supported by 4 legs, means the cupola furnace will be kept by 4 legs. Okay, the internal walls are lined with refractory bricks. Why we use the refractory bricks? Because that material withstand the higher temperature, because during melting of the cast iron or other materials, the very high temperature will be generated, and to withstand that high temperature we use the refractory bricks. Another, its lining is temporary, because the refractory materials, as a refractory material we use bricks, so that will be lined as a temporary. After certain time again it will broken, then maybe again for melting it will be done as a lining with refractory bricks. Now that is the one diagram of the cupola furnace. some legs are there, 4 legs we kept to that but for holding the cupola furnace. That is the charging door through which we entering the charge, means metal, flux and coke. Air blast through which we send the oxygen for burning of the coke. And tires also used for sending the air for burning purpose. Another spark arrestor, smoke will be generated during the melting of the charge, and that smoke will be arrested in that particular zone, and also after that it will be sent outside of the and sent to the atmosphere. And that is the stack zone. Here smoke initially it will be stacked here, then sometimes when we sending the charge here also it will take the preheating in that particular zone. Also charge will be initially it will preheated near about 1050 degree centigrade. At that particular centigrade the charge will be heated initially. Then the melting zone, after the preheating zone all are melting zone. Here charge will be means metal will be melted here, and also after that, that is the reducing zone. Here some other materials means charge materials will be kept here, it will help also to melt purpose. And also combustion zone, here coke, some other materials will be kept here and also taken the burning, and due to burning the metal will be melted. Another things, oil, here after melting the iron here accumulated in that particular zone, and also here tap hole is there, through the tap hole we send the molten metal to the particular ladle or to the particular things are there. In that particular things we store we take the molten metal. Generally we have used the ladle for taking the molten metal, then we will send the molten metal for other applications. Parts of the cupola furnace, what are the parts? Main parts is spark arrestor. Spark arrestor means that part. Okay. Another charging door, we will discuss every part properly. Charging door means here through which we send the charge, means metal, coke, flux to the particular melting zone or combustion reducing zone. Then airbox is there, that is the airbox. Here airbox is there, and that airbox helps to send the oxygen to the particular furnace for burning purpose. Tires also used for sending the oxygen to the furnace for burning purpose. Another tap hole, through the tap hole we taken the molten metal to the ladle, because to that particular well, here particular well is there, in that particular well the molten metal accumulated. After accumulating or after storing of the molten metal, then it will be sent to the tapping hole, and after coming through the tapping hole it will taken to the particular ladle. Then we will use that pouring molten metal to other applications. Slag hole, one slag hole is there. Through the slag hole we emerge out, we taken outside the slag. Slag means some flux material, some impurities we are taken from that particular molten metal through the slag hole. We remove the slag from that particular molten metal. Actually it will accumulated upper side of the molten metal, and through the slag hole we remove the slag from that particular molten metal. That are the main part of that particular cupola furnace. Now we are coming, what are the zones? First is oil zone. Oil zone, the oil zone means that zone. That zone is the oil zone. That zone is the oil zone. Oil zone is started, that is the space between bottom of the tires. Bottom of the tires, here is the tires through which we send the air. Actually the tires, bottom of the tire, that is here tires is present, that is the tire, and bottom of the tire means here bottom portion. Oil zone started from that surface. From the bottom of the tires and the sand bed, that is the sand bed. Here one slope will be produced using molding sand for easily for creating the slope. The molten metal easily goes through the tapping hole to the particular ladle. Means easily we have collected the molten metal through the tapping hole. That is the weld zone. Another molten metal collected in that portion, that is the molten metal zone. Here easily we have collected the molten metal in that particular weld zone. Another things, combustion zone, that is the combustion zone. That are the combustion zone, that part. That is the combustion zone. Combustion zone also known as oxidizing zone. Here combustion takes place, burning takes place of the particular coke, and it is located between the oil and melting zone. Actually combustion zone, that is the oil zone, upper part of the oil zone and the lower part of the reducing zone. Means between that two zone it will varies. That is the combustion zone. Okay. The space between upper side of the oil zone and the bottom side of the reducing zone, that space defined the combustion zone. Here combustion takes place, and height of that zone generally normally varies. Height of that particular combustion zone varies from 15 centimeter to 13 centimeter. That combustion zone varies from the height of the combustion zone. That height near about vary from 15 to 30 centimeter. In this zone, temperature near about 1540 degree centigrade to 1870 degree centigrade varies. In the combustion zone, we have seen that in that combustion zone, temperature varies from 1540 degree centigrade to 1870 degree centigrade in that particular combustion zone, and the exothermic reaction takes place. Means extra heat will be produced or generated to that particular combustion zone due to burning. Means some chemical reaction takes place in that particular combustion zone. So what are the following reactions? The first one, C plus O2 produce CO2 and also heat will be generated. Another, Si, silica plus O2, that will form SiO2, silicon dioxide, and also heat will be generated. Another, manganese 2Mn plus O2, it will form 2MnO, manganese oxide, and also generate the heat. Means exothermic reaction takes place, means extra heat will be generated in that particular combustion zone. What is a reducing zone? Reducing zone, that zone is the reducing zone. The upper part of the combustion zone and the lower part of the melting zone, that reducing zone varies between that thing. Means reducing zone varies from upper part of the combustion zone and lower part of the melting zone. That zone is the reducing zone. That is the reducing zone. That is the reducing zone. And in that zone, what happened? Temperature in that zone particular near about 1200 degree centigrade. It maintain the temperature near about 1200 degree centigrade. And also in that zone, what happens? Now carbon monoxide changes. Okay, in this zone CO2 changes to carbon monoxide. What happens? CO2 plus coke, carbon reacted between that two things and form the carbon monoxide. Two molecule carbon monoxide will be formed due to that reaction. Carbon dioxide plus coke reacted with, after reaction the carbon monoxide will be formed in that particular reducing zone. Melting zone. Melting zone is the upper part of the reducing zone as the lower part of the preheating zone, that is the melting zone. That part is the melting zone. Okay, and in that melting zone what happens? The following reaction takes place. What reactions? Now ferrous iron plus carbon monoxide, both by the reaction of that two compounds, what form? Na Fe3C plus again carbon dioxide will be formed in that particular melting zone. Preheating zone. A preheating zone mainly that is the upper part of the melting zone and lower part of the preheating zone. Lower part of the charging door, that is actually charging door here. Means that zone is the preheating zone. Means upper part of the melting zone and continuous up to bottom level of the charging door. Bottom level, that is the actually here charging door will be, that is the charging platform, that is the charging door. Means bottom level of the charging door and upper part of the melting zone. Between that zone, the preheating zone will be vary. And when we passes the charge, flux, coke and metal, then it will again preheated. Means after coming to that particular zone, it will preheated at near about 10 to 1050 degree centigrade. And means it will main objective of that preheating zone to preheat the charge near about 10,050 degree centigrade. Stack. Actually stack is that is the empty portion. That empty portion is called stack zone. The empty portion is called means upper part of that particular furnace, that is the empty zone, means that is the stack zone. Cupola above the preheating zone, means above zone, the above of the preheating zone, actually that zone is called stack zone. It provides the passage, actually that is the fully empty spaces and through which the hot gases will be go outside. Outside meaning goes to the atmosphere from the cupola furnace. Easily it will go out to the atmosphere. Actually that is the empty zone, means that is called stack zone. Charging of the cupola furnace. What before the started of the furnace, before the operation, what we have done? Now we are taking the flux, metal and coke. After taking that, actually that three things are called charge. After taking that things, we have passed through the charging door, okay, to the particular cupola furnace. And when it will come through the preheating zone, it will again preheated. After preheating, then one by one layer will be formed and it will be accumulated. Means one layer of the coke, one layer of the flux and one layer of the metal will be accumulated to the particular cupola furnace. So the height in that cases, and when cover plates are positioned, the blower is started. Means upper cover plate will be closed up. Then in that cases are position, then blower will be started. When we started the blower, the oxygen comes to that particular cupola furnace. So height of the coke charge in the cupola in each layer varies generally from each layer of the coke, then metal, then flux. It will generally vary from 10 to 15 centimeter. Means charge means flux, coke and metal. Actually one by one layer will be accumulated in that particular furnace. So every layer generally varies from 10 to 15 centimeter. And in that cases, the requirement of the flux, that will be depends upon the quality of the charged metal. Fully addition of the flux, that will be depends upon the quality of the metal or scrap. Working of the cupola furnace. So in that furnace we are seeing that first we charge consists of scrap means metal scrap, coke plus we are taking as a charge. Then charge is placed layer by layer, means layer by layer coke, flux and metal layer by layer it will be accumulated to that particular furnace. Then air enter through the bottom tires. Here bottom tires is there. bottom tires is there. Through the tires, air will be goes to the furnace. Then this increase the energy efficiency of the furnace. Means here when air will be goes to inside the furnace, it will increases the energy. And here already coke is present in that particular zone. Coke is present. Means when oxygen will come and coke will be consumed. Means we will started the burning, then coke will burn. The burning of the coke with the help of oxygen, it will start it. And due to starting of the burning, step by step, flux and metal, it will start the melting. So hot exhaust gases rise up. When it will take the burning, then it will start the melting, and due to melting, the molten metal comes to that particular oil surface. Oil one zone is there, oil zone is there. Means here molten metal will be accumulated here. After accumulation of the molten metal, we are taken through the tapping hole is there. Through the tapping hole, easily we take the molten metal to the particular ladle. A continuous flow of iron emerges from the bottom of the furnace. Means after melting of the metal scrap, it will converted into molten metal, then it will come to that particular oil zone, and after coming to that particular oil zone, then we are taking the molten metal through the tapping hole from the oil zone. The slag is, one slag hole is there, particular one slag hole will be present to that particular furnace, and when molten metal come to that particular oil zone, generally the upper surface of that melting zone, the slag will be accumulated. Slag will be accumulated. Then we easily remove the slag from through the slag hole. Means actually that is the one impurities. We are considering that slag as a impurities. We remove the slag from the melting zone through the slag hole. Then after removing the slag, we are taken the molten metal from the oil zone through the tap hole. So what are the operation we have done to that particular cupola furnace? First preparation of the cupola. Okay, means we are taking the ready of that cupola furnace, then we will put the charge and then other processes we have done. First we prepare the cupola. Then firing the cupola, means coke is there, and through the entering of the oxygen to the cupola furnace, burning will be started. Then soaking of the iron, means then we put the iron, means metal scrap, coke, flux entering to that particular combustion zone. After soaking of the iron, then we opening the air blast, means we sending the air to that particular cupola furnace. Means it will continuing the burning will be the burning of the coke with the help of oxygen, it will be continuing, and due to continuing of that burning, the firing also done, and due to that thing, the molten metal, it will be converted due to metal scrap. Okay, and then after generation of the molten metal, we are taken from that particular cupola furnace. We have collected the molten metal from the furnace to the tapping hole. Then we closing the cupola. Then it will preparation the cupola, then firing the cupola. Means again the process will be started. Now in case of preparation of the cupola, what we have done in that time, slag and metal adhere to the cupola lining. Means one brick surface is there. Refractory bricks there to the cupola furnace. Why we use the refractory lining with the made of bricks? Because it withstand the higher temperature. So slag metal adhere to the cupola lining from the previous run. After starting the operation, from before that we removed that slag and metal which is stick to the surface of the cupola furnace. Already the slag will be stick to that particular surface, brick surface means lining surface, refractory lining surface. First we removed the slag and metal, then lining of cupola is remade. Again we have prepared the refractory lining. Again we prepare the refractory lining freshly. Okay, the bottom plates are swung to closing position supported by props. Means, and the bottom plates are kept to the closed position. Okay, supported by some prop we have used for closing purpose of the bottom plates. The sand bed, we prepare the sand bed to the lower part of the furnace, because and made using the molding sand, and also we provide the slope. Why we provide the slope of that sand? Because when molten metal comes to that particular weld zone, so here easily goes out through the tap hole. That's why we provide the slope to that particular cupola furnace. Actually that slope will be made using the molding sand. Firing the cupola. So in that cases the cupola is fired by kindling wood at the bottom. Means some wood we have used for burning purpose at the bottom of the cupola. Then this should be done up to 2.5 to 3 hours. Means using wood we are doing the burning up to 2.5 to 3 hours before the molten metal is required. Means before generation of the molten metal we are doing the burning up to 2.5 to 3 hours. Okay, means 2 hours 30 minutes to 3 hours. Then top of the kindling wood a bed of coke is built. Means just top of the wood just coke is kept. Okay, and due to firing of the wood after certain time the coke will also started the burning with the help of oxygen. The height of the coke bed is maybe vary from 50 centimeter to 1 centimeter. Actually that depends upon the size of the cupola. The coke bed that will vary from 50 centimeter to 125 centimeter. Okay, actually that size will be vary due to size of the cupola. If the size of the cupola is higher, so coke bed size also will be higher. Means it will come towards the 125 centimeter. Another soaking of iron. So in that cases the furnace is charged fully. It is maintained for about 45 minutes. Means in that cases we fully charged, means fully filled up by the charge, means metal, flux and core fully charged, and it will maintain about 45 minutes. Then charge is slowly heated. Means after fill up of the charge using charge means flux, metal and coke. After filling up of that charge, then we started the slow heating. Then during that stage air blast is shut off, and in that time we shut off the air blast and iron is soaked in that time. Opening of the blast air. At the end of the soaking period, the air blast is opened. At the end of the soaking period, we open the air blast, and the tapping hole is closed. Means when the molten metal will be generated, so in that time we close the tap hole, because otherwise if we do not close the tap hole, so when molten metal will be generated, that will be goes out. So before generation of the molten metal, we close the tapping hole using a plug. Using a plug, we close the tap hole. When the melting precedes and molten metal is collected at the bottom. Now we are coming to the discussion of the opening of blast air. Okay, at the end of the soaking period, now air blast will be opened. Due to opening of the air blast, the oxygen will goes to the cupola furnace. The air blast is opened, then the tapping hole is closed by some using plug. Using some plug, we close the tap hole, means tapping hole will be closed using a plug. Then melting proceeds and molten metal is collected at the bottom, means that is the oil section of the cupola furnace. After pouring of molten metal, what happens? Here sufficient amount of molten metal will be generated and then it will be collected at the oil section. Means oil section means oil part of the cupola furnace. And the upper side of the molten metal, the slag will be accumulated. That slag material will be removed through the slag hole from the cupola furnace. Another, then tapping hole will be opened and molten metal is flowed through the tapping hole and it will be collected to the ladle. And then the molten metal will be used some other purpose. It will be taken from ladle. Another, that then same procedure will be we follow repeated times until the charge is melted and the operation will be over. Up to that time again we repeated that procedure. And closing the cupola, when the operation will be over, the air blast will be shut off. Means we does not provide or does not send any extra oxygen. Means then air blast will be shut off. The bottom of the furnace will be again, the bottom of the furnace will be opened by removing the prop. By removing the prop we opened. Then we are doing some cleaning to the cupola furnace. What are the advantages of the cupola furnace? It is simple and economical to operate. And also cupola furnace refines the metal charge, removing the impurities through the slag hole easily. High melting rates, easy of operation. Operation is very easy. And also adequate temperature also we control that particular cupola furnace. And chemical composition also we have control here. Efficiency varies from 30 to 50%. And less floor space requirements because the cupola furnace is placed vertically to the particular space. And due to vertical position, the floor space, less floor space is required. What are the disadvantages? Means when melting will, during melting time, what happen? The coke and iron contact each other. And due to contact, some certain elements like silicon, manganese are lost. Means we mixed with the molten metal. And sometimes other like sulfur also may added to that particular molten metal. So in that cases, that will be the final analysis of the molten metal is very difficult. Means purest form is not get to that particular analysis. Close temperature control is also difficult. Sometimes very high temperature will be generated to that particular cupola furnace. So at that time the temperature control is very difficult. And before that we will show one video about the cupola furnace. Now I will show one video about the cupola furnace. Cupola is used to melt the cast iron. Generally cupola furnace will be used for melting the cast iron. What are the components of the cupola furnace? First one, cell. Second thing, foundation. Third is tires. Fourth is wind belt. Fifth is blower. Sixth, slag hole. Then charging door. And chimney or stack. That are the vital parts of the cupola furnace. First one, we are discussing about the cell part. Cell is a vertical and cylindrical in shape. Generally, that is the vertical column that is made of steel cell, because it is a corrosion resistant material. Generally, thickness of the steel cell 6 to 12 millimeter thick, and the lining will be made of bricks or bricks and clay, means it withstand the higher temperature during melting time. Generally silica SiO2 and alumina Al2O3, using that things we prepare the bricks, means refractory lining we have prepared inside the steel cell. Foundation generally made of steel columns or brick will be used for formation of the foundation. That is the foundation, maybe steel column or maybe made of bricks. That is the steel column foundation. Brick foundation, that is the brick foundation, and that is the steel column. The bottom cell consists of drop bottom door. Here drop bottom door is there, and through which we remove the debris like coke, slag, etc. can be discharged through the drop bottom. Tires will be used for combustion of the fuel is delivered through the tires. Air will be delivered through the tire to the combustion chamber. That are the position of the tires. Tires generally at the height of 0.6 to 1.2 meters above the working bottom. From the working bottom, distance near about 0.6 to 1.2 meters. Wind belt. Air is delivered to the tires from a wind belt, which is a steel plate duct. Means we send the air through the wind belt to the particular tires, and through the tires it will go to the inside of the cupola furnace. Wind box is mounted on the wind box mounted here, just outer shell of the steel cell. A high pressure fan, means blower will be connected to that particular wind box, and it will be used for sending the air to the particular furnace. Through the pipe or duct is present to that particular position. Slag hole. Slag hole will be used for remove the slag. It is located about 250 meters below the center of the tires. Means from the tires it will presented here. That is called slag hole. Near about distance is 250 millimeter. It is used for removing the slag. Charging door. Charging door, it is situated above the tires near about 3 to 4 meters above. 3 to 4 meters above from the tires, the charging door will be present. Through which we pour the metal coke and flux to the cupola furnace. That are the charging material, means metal coke, metal flux and coke. That is the metal, flux and coke. And through the charging door we send the charge to the particular cupola furnace, and it will be accumulated layer by layer. It is accumulated layer by layer. Through the charging door we are sending the charge, means metal, flux, core, and chimney or stack. The upper part of the charging door, that is the stack zone or chimney zone. That cell is usually continued 4 to 5 millimeters above the charging door to from the chimney. The above part is the stack zone. That is the spark arrestor. Means here hot gases goes through to the spark arrestor, and then from the spark arrestor it will go to the atmosphere. Zones of the cupola. What are the zones? First is melting zone. Melting zone, that is the form of the top of the coke bed and extend up to a height of 900 millimeter. From the coke bed it will light up to 900 millimeter. That is the melting zone. That is the melting zone. Temperature near about 1600 degrees centigrade. What are the reactions? Fe plus CO, it will form the Fe3C plus CO2 in the melting zone. Combustion zone. What happens in case of combustion zone? It is situated normally 150 to 300 millimeter above the top of the tires. Generally, above the top of the tires, it will vary from 150 millimeter to 300 millimeter. 150, it will vary from 150 to 300 millimeter. That is the combustion zone. What are the reactions? C plus O2, CO2 plus heat generated, Si plus O2, silica dioxide plus heat will be generated, Mn plus O2, that is manganese oxide also formed and also heat will be generated. Fe plus O, ferrous oxide, and heat will be generated in that combustion zone. Now we are coming to reducing zone, oxidizing zone. In that zone, in between melting zone and combustion zone, it will vary. That is the reducing zone. It will vary from melting zone and combustion zone. CO2, reduction of CO2 means from CO2 it will reduce to CO aqueous. Near about at temperature near about 1200 degrees centigrade. CO2 plus CO converted into CO plus CO2 means heat will be abstracted, means reduces. Heat will be reduces here. Crucible zone, it is between top of the sand bed and the bottom of the tires. Sand bed, that is the sand bed, okay, and bottom of the tires. It will, in between that zone, the crucible zone will be positioned. That is the oil zone. Means it is also called oil zone. Here molten metal will be accumulated here. The molten metal accumulates here. Then preheating zone. It is start from top of the melting zone and extend up to charging door. That zone is the preheating zone. Extends up to charging door. That is the preheating zone. That is the preheating zone. It is also called charging zone also. Charging materials are generally fed into this zone and get preheated. Preheating zone, we fed the charge to the preheating zone and again it will be preheated. Stack zone. In that particular zone, what happens? It extends stack zone up to cupola, means spark arrestor. That is the stack zone. Means hot gases will be goes out through the spark arrestor to the atmosphere. The gases generated within the furnace and carried to the atmosphere by this zone. That is the spark arrestor.